Have you ever really thought about what happens in those few critical milliseconds during a car crash? It's not luck, and it's definitely not magic. It's this incredible hidden science, an entire system of engineering designed to do just one thing: keep you safe. So let's just start with a really simple question. What is it that actually protects you? Is it the seatbelt, the airbag, the strong steel frame of the car? What's the most important part?
Well, the thing is, the real answer isn't a single feature. And, thinking of it that way is actually a really common mistake. The truth is, your protection comes from a whole philosophy of safety engineering. Yeah, it's a system, a whole bunch of things working together where every single component has a job to do, and it's all timed perfectly to manage the insane forces of a collision. It's like a high-speed symphony of physics and tech, all playing out to protect you.
Okay, let's get into it. To really get how a car can protect you, you first have to understand the fundamental problem it's trying to solve. And that problem is energy. A huge, destructive amount of energy.
Right at the heart of every single crash is this one powerful equation: kinetic energy. It's the energy of motion. And literally, everything that happens next, every piece of bent metal, every airbag that deploys, it's all a reaction to this. Every single safety feature is just trying to manage the force that this formula represents.
And here is the really critical part. See that V for velocity? It's squared. That means if you double your speed, say from 30 miles an hour to 60, you don't just have double the energy. You have 4 times the energy. It's this exponential jump that makes high-speed crashes so devastating. And it's why managing that energy is absolutely everything.
So how do car designers even begin to deal with all that energy? Well, the absolute best way to survive a car crash is to not have one in the first place, right? And that's the whole job of what we call active safety systems. And it's so important to get this distinction. You've got active safety, which is proactive. It's trying to stop the crash from ever happening. Then you have passive safety, which is reactive. It kicks in to protect you when a crash is unavoidable. So how do these active systems actually work? Well, it's kind of like giving your car its own set of reflexes. Take a collision warning system. It's basically a 4-step process that happens in a flash. First, it senses the road with radar. Then it analyzes for danger. Then it warns you. And if you don't react, it intervenes for you, slamming on the brakes.
And you're probably familiar with a lot of these technologies. They're becoming super common. Things like adaptive cruise control, blind spot detection, lane departure warnings. They all act as a sort of digital co-pilot, constantly scanning what's around you to help keep you out of trouble.
Okay, but let's say a crash is about to happen. It's unavoidable. This is where passive safety takes over, and it starts with the actual structure of the car itself.
Now, you might think, and it makes sense, that a car built like a tank, something just incredibly strong and rigid, would be the safest thing to be in. It's a really common idea, but it's totally wrong.
The secret to modern car safety isn't about brute strength. It's not about being rigid. It's actually about controlled collapse. So, why on earth would you want a car to collapse?
And this is where we get to the brilliant concept of the crumple zone. See, instead of trying to resist the force of a crash, these areas are designed to yield, to fold and collapse in a very specific, predictable way. Think of it like a boxer rolling with a punch. By crushing, the car literally sacrifices its own body to soak up that violent kinetic energy, and crucially, to stretch the impact out over a few extra milliseconds.
This whole idea was pioneered by an inventor named Bela Barani, who patented it way back in 1952. His concept just completely flipped how engineers thought about safety. The idea is that the car body sacrifices itself to save the people inside. So what you end up with is a car with 2 different personalities. You've got the soft, sacrificial crumple zones on the outside that are designed to absorb the blow, and then you have this incredibly hard, reinforced safety cell on the inside, basically a survival pod that's designed to stand tact and keep anything from getting to you. So now, let's move inside that safety cell, inside that bubble, because this is where an unbelievable high-speed ballet of safety devices goes off faster than you can even blink.
I mean, just look at this timeline. We're talking about thousands of a second. At just 15 milliseconds, before you can even process that you've been hit, these little explosive charges in your seatbelt, the pretensioners, have already fired to yank out any slack and pin you to the seat. By 30 milliseconds, the airbag is already coming out, and by 50, your body, which has been slowed by that tight seatbelt, makes contact with a fully inflated cushion. It's just an unbelievably fast and perfectly choreographed sequence of events. And all of these different parts, the seat belts, all the different airbags from the front to the side, even things like collapsible steering columns and padded dashboards, they're all designed to work together. It's one single integrated system to manage the forces on your body and slow you down as gently as possible.
So we've gone from crumple zones to intelligent sensors. After all these decades of innovation, what's next? Where is all this technology heading?
Well, the future is all about integration. Those lines we talked about between active safety that prevents a crash and passive safety that protects you during one, those lines are blurring. The goal is to create one seamless, intelligent shield that can anticipate danger and make any impact that does happen completely survivable.
Which, leaves us with a pretty final, provocative thought. As all these systems get smarter and more connected, are we actually on a path to engineering the car crash completely out of existence? Could it one day become a thing of the past?